Hi everyone, this is Mrs. GA, and today we're going to talk about quadratic functions and how to find the maxima and minima. So first we're going to talk about how to interpret different parts of quadratic functions. So when they're asking you to find these different things, what are they really asking you to find? So if they're asking you to find the maximum or minimum value, that is always going to occur at the y value of your vertex. So if you think of a parabola is either going to have a minimum if it's upward facing or a maximum if it's downward facing, and that point is always going to occur at the vertex. So if a minimum or maximum is what you're looking for, it's going to be the y value of the vertex. X-intercepts, I want to remind you that we set y equal to 0 and then solve for x. And to find the y-intercept, we set x equal to 0 and solve for y. And this value is also called the constant. Okay, so standard form of a quadratic equation looks something like this. Some people also call this vertex form. So you may see either name for it. And again, it looks something like this. F of x equals a times x minus h squared plus k. And that's any quadratic function that looks like this can be rewritten in this form. So we really like vertex form for graphing because it's really easy to see where the vertex is. It's hk, noting that in the equation it says minus h, implying you take the opposite. And of course, if the parabola opens upward, a is greater than 0, and if the parabola opens downward, a is less than 0. All right, so we're going to start by learning how to rewrite a quadratic equation in that standard form. So this is going to involve us completing the square, and remember our goal is to make it look something like this: y equals a times x minus h squared plus k. So first we need to focus on how to create this binomial squared. So the first thing I'm going to do is I'm going to isolate my x squared and x terms. So I'm going to subtract 23 from each side. And I'm going to replace f of x with y. They're interchangeable. Okay, so before I complete the square here, which will allow me to make a binomial squared, you can't complete the square if x squared has a coefficient. So I do need to factor out the 2. So I have 2 times x squared minus 6x. And then I'm going to leave a little blank spot for us to find the number that completes this perfect square trinomial. So there is a formula for this that you need to know. The formula is b over 2 squared. This number will complete our perfect square trinomial, so we can write a binomial squared. So I see here that my b value is negative 6. So I have negative 6 divided by 2, and then I'm going to square it, which becomes negative 3 squared, which is positive 9. Now this next step is a step that a lot of people forget. As remember, this is an equation, and if I do something on one side of the equation, I need to do the same thing on the other side. And this one is a little extra tricky because it looks like we added 9, but since we added 9 inside this group, which is being multiplied by 2, we actually added 18. So I need to go and add 18 to the other side of our equation. So what we have left is y minus 5 equals 2 times, and then here I can factor this trinomial, and your little trick is that when you factor it, this b over 2 value will always be the number inside your factor. So since it's negative 3, it's going to be x minus 3 squared. So be careful with this step. Remember, if you're adding something to the right side of your equation, you need to add the same amount on the left. Now, if you compare what we have and what we would like our equation to look like, you can see that all we need to do is add 5 to both sides, and it is in standard form. So from here, you can see that our vertex is positive 3, positive 5. If you look back at our original equation and set x equal to 0 right here, we can see that our y-intercept is at 0, 23. And this graph actually doesn't have any x-intercepts because its vertex is above the x-axis, so it would look something like this. Let's say here's 3, 5. And I have an upward facing graph, so it looks something like this. And this should be 23, and let's say this is 3, 5. Now this is not drawn to scale, and of course this is just a sketch. You should also be able to provide a much more accurate one if requested. Okay, let's try one more example together. So here again, we're going to start by rewriting this in standard form. So let's start by isolating our x squared and x terms. So I'm going to subtract 49 from each side. And then before I complete the square, I do need to factor out that a value. So we have 5 times x squared minus 6x. And then I'm going to leave a blank right here so we can find the number that completes our square. So using our formula, I see that it's going to be negative 6 over 2 squared, again, which is negative 3 squared, which is 9. So I'm going to add 9 here, which actually is adding 45 to the right side of my equation. So I need to go and add 45 to the left side of my equation. And what I have left is y minus 4 equals 5 times x minus 3 squared. And then let's take one last step and add 4 to each side. And now my equation is in standard or vertex form. I can see that the vertex is 3, 4. Looking back at my original equation, if I set x equal to 0, I can see that my y-intercept is 0, 49. And again, if you sketch a really, really rough graph of this, you see that we have a vertex that is above the x-axis and it's upward facing. So we have no x-intercept here. So this would be at 49 and this vertex is at 3, 4. And of course, this is not drawn to scale. So at this point, I'm going to ask you to pause the video and see if you can try rewriting this quadratic equation in standard form. Okay, let's check your work here. So you should end up with the equation y equals 3 times x minus 1 squared plus 7. And you could see I sketched a little graph, so my vertex is at 1, 7, my y-intercept is at 0, 10, and you should be good to go. Okay, let's try another example together. So here we see the quadratic equation negative x squared plus x plus 2, and we're going to start again by rewriting this in standard form. So again, let's isolate my x squared and x terms. So I'm going to subtract 2 from each side. So we have y minus 2 equals negative x squared plus x. So before I complete the square, I do need to factor out the negative. So I have negative x squared minus x, and then I'm going to leave a space for where I'm going to complete the square. Now this one is a little bit trickier because we have a b value that is odd. So if I use my formula, I have negative 1 over 2 squared, which becomes positive 1 over 4. So that's what I'm going to add right here. But really, I subtracted 1 over 4 from the right side, so I'm going to subtract 1 over 4 from the left side. And what I have left here is y minus 9/4 equals negative. And then remember, we have a little trick for factoring these. This b over 2 value, which in this case is negative 1/2, will always be the value inside my factor. So I have x minus 1/2 squared. So it is really useful to know that little trick. And then to finish putting this in standard form, all we need to do is add 9/4 to each side. So we have negative x minus 1/2 squared plus 9/4. and this is our equation in standard form. So I can see here that my vertex is going to be at 1/2 9/4. So I'll write that on the side. Okay, so now they ask us to find the x and y intercepts. So remember, to find the x-intercepts, or maybe it's only one x-intercept, we have to see. We set y equal to 0 and we solve for x. So I'm going to start by dividing both sides by -1 so I can factor. And here we get x minus 2 times x plus 1 equals 0. So that gives us two solutions, positive 2 and -1. So my x-intercepts are 2, 0, and -1, 0. Remember, the intercepts are coordinates, so make sure you write them as coordinates. To find my y-intercept, let's look back at the original problem. If I set x equal to 0, I can see that my y-intercept is 0, 2. And now we have all the information we need to get a nice, accurate sketch. So let's say here's our vertex at 1/2 9/4. Let's call this 2. And then we have x-intercepts at -1 and 2. So it looks something like this. And this is 1/2 9/4. So again, a really rough sketch, but good enough to show all of the important information from our quadratic function. Okay, so at this point, I'm going to ask you to pause the video and see if you can give this one a try. Okay, so for this one, you can see that, again, we have that b value that's odd, so it's a little bit trickier, but if you square -1/2, you get 1/4, and although it looks like we're adding 1/4, we're actually subtracting 1/4 from each side. And remember, to factor something like this value is always going to be that b over 2 value. So this should be your standard form equation, giving you a vertex at 1/2 21/4, and you have a y-intercept at 5, and it is downward facing. Okay, so now we're going to talk about a different way you can find the vertex formula, and this is instead of having to rewrite your equation in standard form, you can use this formula right here, which is x equals -b over 2a, to find the x value of your vertex, and then of course to find the y value, you plug it into your function. So the maximum or minimum value would be f of -b over 2a. Be careful, this is very similar to the completing the square formula, but it is for a completely different thing, so make sure you know those two different equations. Okay, let's give one of these a try. So here we're going to find the vertex, and we're going to do this with the formula, and then we'll see if we can also find the intercepts and sketch a quick graph. So again, we're going to use the formula x equals -b over 2a. So here we have -4 over 2 times 1. So we have x equals -2, and now let's find f of -2. So we get -2 squared plus 4 times -2. So here we get +4 minus 8. So f of -2 is -4. So our vertex is -2, -4. Now let's see if we can find the intercepts. So to find the x-intercepts, again, we're going to set y equal to 0. And this one we can solve by factoring. This one you can factor using GCF, x times x plus 4. And we get two intercepts at x equals 0 and at x equals -4. So we're going to write those as coordinates. And you can see that this first one is not only our x-intercept, but it is also our y-intercept. So now we can sketch a really quick graph. So let's say here's -2, -4. I have an intercept at 0, 0, and -4, 0. So it would look something like this. Again, this is -4, and this is -2, -4. And there you have it. Okay, go ahead and pause the video and see if you can find the vertex of this quadratic formula using the vertex formula, and then see if you can also find the y-intercept and sketch a graph. All right, so you can see here I used my vertex formula, got x equals 1, substituted it to get y equals -3, so here's my vertex. This vertex is below the x-axis and it is downward facing because of that a value. So here we actually don't have any x-intercepts, and our y-intercept would be at 0, -5. Okay, that is all for today's video. Thank you so much for watching.